We're going to look at foundational types in Python and how it can enhance your developer experience and get teams to be more productive. Let's jump in. So have a look at this code over here. See if you can understand what it's supposed to do if you were going to use it. And also specifically try and figure out what the error is that you're getting over there. Firstly, look at lines 13 to 19 to understand what the logic is there. And let's look at the code that's generating this error for us. So we're creating a character and we're passing in that data. Typically, this could take you a while to figure out what the error is. And this is what we're going to focus on right now. We're going to look at how you can use types to make it incredibly easy to understand and to fix these types of issues. Look at this function over here. This is an untyped function. Typically, you'll never do that. And also here is you're using the docstring to create your contract inside docstring. That would be terrible. So before types, that's what you had to do. So here we're using that function and we're getting this error over there. The error, there's nothing that's protecting us against sending in this case, a list, which we're sending in, and the function doesn't cater for it because list does not support that .strip method over there. Have a look at these two functions and then compare them to line 11 to 13. This is what a function looks like when you've annotated it with types. Over here, we are saying that we're expecting a string and we're returning a string value. That's the basic idea with types. So what we have now is we have line 4 over there. The moment we type that line, the type checker is telling us argument of type list string cannot be assigned to parameter name of type string in function say I. Instantly we get that warning. We can still execute the code. That's something important to note. The type checker warns you, but Python is still a dynamically typed language. So type annotations, they guide you, they're documentation for developers, they help your tools, they also help frameworks, but they do not affect Python's execution. We're going to run through basic types real quick. So that's an example of how you annotate an int and then a float, bool, string, bytes, none type. Moving on here to built-in collections. So you no longer need to import collections like you used to from typing. You can just use it lowercase list as an example for your type annotation. List of integers, a tuple with an integer and a string value, only those two values, and then a tuple with an unspecified number of floats. It has to be floats, but it's unspecified. You use the ellipsis to indicate that. Then a set of strings, a frozen set of ints, a dictionary with string key and integer values. Good. So let's now refactor that original code that we were working on. First thing we're doing over here is we're creating type aliases. You used to have to import type alias. Now you can just use them like in an idiomatic way like this. We're creating an alias called attribute value, and we're setting that to the type annotation int union none, so either of int or none. Then we're doing another one, type attribute, that references attribute value. So it's a dictionary with string values, and it expects then for string keys, and for a value it expects an int or union none. Type character would be a dictionary of string keys and any object. Let's move on. So here we are creating a frozen set of string values. That's all the different values that we're going to check against. And this is where the function gets created now. And we've got our spec in that function. Again, we're expecting a name with a string value. And then we are also expecting attributes, which will be any of the type alias attributes. And then we're going to return a character. I'll show you now how this works in the IDE. Let me just show you something over here. So look at line 39 to 43. So that's where we're returning the character. If we do anything that's not within the type annotations, we will instantly get a warning, and I want to show you that as well. And here is a valid usage of the create character. I'm going to show you now, we're going to make the same error that we originally had, how the type annotations are warning you and also telling you what the error is. One of the great things with type annotations is it guides developers as they're working. So the instant I type create character, I get the specification of the function, basically the contract of the function. It's telling me there that create character expects a name or value string of type string and an attribute of type attributes, and we need to return a character. I can drill into those types as well if I need to. Let's look at what an error would look like. The moment I use the type, and that, by the way, if you go back to the original code that was erroring, the error here is now very clear. We are sending in string values for 2 of the attributes, and that's not accepted. So you can see here, argument of type dictionary string cannot be assigned to parameter attributes of type attributes in function. And then it gives you the exact error. Literal 12 is not assignable to type attribute value, not assignable to int or none. And remember, those are the two, that's what the alias said. So let's look at this inside. Okay, before I do that, I want to look back at this code without type annotations. Compare this now. If you're a developer and you need to use create character, it is going to be impossible for you to know without reading some form of documentation. Typically, teams do not document it, so you're going to have knowledge that's not documented, shared among team members. You'll have to search code, and that's where it becomes messy, and people start blaming each other because they did not follow the unwritten rules. So that's where type annotations helps teams keep up development velocity. Okay, so this is Visual Studio Code over here. I want to show you that exact function, and now so it's showing me exactly what I need to do. And if I make a mistake, so let's turn this into a string, then I instantly get a warning. It's telling me, and this is what you want. You want to know exactly what you are doing in your code, and whenever you break anything, you want to instantly know about that. So I can still execute the code, and I'm still going to get the error. That's it. This was a quick overview. If you are looking for a deep dive into Python type annotations, I created a mastering Python type annotations video. It's a little bit longer, but it really goes deep into this. If you want to learn how to install our Git repo with this exact code, I'm going to focus on that right now. If you got what you needed, thank you for joining, and see you in the next video. Have a great day. Let's get this code to execute on your machine. So what you'll do is, you've got an empty folder. Go to our GitHub repo, go into Understanding Python Season 1. Clone that repo, git clone. And once you've cloned it, go into the folder and then check the branch, switch to that branch. Understanding Foundational Types, that's the branch for this specific episode. Once you're in that, you need to UB-sync. That'll install all the different packages, source into the virtual environment, and execute the code. It's easy as that. All right. Have a good day, and let me know what you want me to cover next. Cheers.